Hello, everyone, and thank you for joining us for the first session of the Oxygen Talk, brought to you by the Oxygen Alliance. The Oxygen Talk is different than our usual concentrator talk. In the concentrator talk, we have experts discussing a topic related to technical questions about concentrators. In the Oxygen Talk, we'll have experts discussing a topic related to oxygen delivery. My name is Amarpreet Rai, and I'm currently in New York, and I'm very pleased to be hosting the Oxygen Talk today. Joining me are my colleagues, Timothy Matonga and Jerry Douglas, along with our usual technicians that you have come to know and love from OpenO2 and Sanrai. From OpenO2, we have Mwawi Lungu, Mtedo Sinjani, Sharon Ngozo, Clement Mbobe, Aubrey Jakunda, Chimoimoi Diese, Tobias Benda, Efa Solomon, Linda Mission, Neferson Kata, and George Ikwangwa. From Sanrai, we have Paulina Mohosho, Kulwinder Singh, and Masofa Mojaji. For those of you who may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time to discuss different aspects of oxygen concentrator assessment, use, and maintenance. And remember, you can always send questions by email to info@oxygenalliance.org, and we will do our best to respond during the next concentrator session. Just a reminder, we ask everyone to keep your videos turned off and your microphones muted unless you are asking a question. It is now my pleasure to introduce Peak Scientific, who will be presenting on today's Oxygen Talk. Peak Scientific was established over 20 years ago in Scotland. They are a leading innovator in the design, manufacture, and support of high-performance gas generators for analytical laboratories with direct operations in every continent around the world. At the heart of Peak is a focus on doing the right thing. It's an informal approach, but one that is well known and understood throughout their business. It is their values that led them to pivot during the COVID-19 pandemic and has led them to volunteer their time to educate us all on the theory, troubleshooting, and maintenance of PSA plants. From the Peak team today, we have Tom Steele, the Global Training Manager, who will primarily be presenting. We also have Danny Livingstone, who is the Production Training Manager, who will be available to answer questions, along with Fraser Dunn, who is the Design Engineering Manager. We'd like to give a huge thank you to the entire Peak team for supporting the Oxygen Alliance and all of their time and effort spent in preparing their presentation today. With that, I'd like to turn it over to Tom. Thank you.
Right, thank you, everyone. It's a great pleasure to be allowed to join with you today, and welcome to everyone, whatever part of the globe you may be in. What I'm going to do is I'm going to hand over to Fraser just to say a few words about Peak Scientific itself, and then we will go straight into the presentation. So over to you, Fraser, for a few words about Peak Scientific.
Thanks, Tom. I think Amarpreet summed up Peak pretty well, and for a very brief history going back a few years, we decided to look more into oxygen off the back of the unfortunate events resulting from the COVID pandemic. And it's been an absolute privilege to be given this opportunity today to share some of our experience, not just in oxygen, but in PSA plant manufacture and troubleshooting with all of you. And it's certainly been an absolute privilege to work with the team at Oxygen Alliance on this. So I hope you find it useful. But again, just to reiterate that this is the start of something for us. This is not just a presentation and then we move on, but we want to continue to be available to help, particularly the Oxygen Alliance and the wider group as and when we can. So thank you all very much, and over to you, Tom.
Right, okay, let's get the presentation up and let's get started. Right, right. Hopefully everybody can see that. So let's go through in a bit more detail what this is all about. So peak gas generation, and we're primarily talking about O2 oxygen generators. So here's Peak's solution to oxygen. We have 6 models. So the models are expandable. So when you start at the base model, you can then build on that, and you can go from 70 litres up to 480 litres of oxygen, and with purities from 90 to 94%. So very cost effective, very purity. We are a quality company. We do build quality product, energy efficient, safer supply as well. It's, you know, the safety issues with high volume oxygen, whether it's in cylinder version or whether it is in liquid form. So you have none of that, and also eco-friendly. Just a quick look at the capacity. So we can go from 70 litres up to 480 litres. Pressure is a 7 bar input with an output maximum pressure of 5 bar. There is just showing you some of the setups. Now we can join multiple units together if we require higher volumes. You can see the modular stage here of the generator, where we start with the base model, and you can add extra banks of zeolite to the unit to expand your output flow. Come on. Oops, wait now, this is frozen for a second. There we go. So let's have an overview of the technology. Obviously, you guys have been working with oxygen concentrators. So really the technology from the zeolite side doesn't change. We are going to use PSA system, where one tank is pressurized, and that's going to absorb the nitrogen, and the other tank is going to be depressurized, so we flush any of the nitrogen out to atmosphere. So here we are. That would be a typical setup. You see your air coming in. What we have at the bottom there is a 5-3 valve that will either direct the incoming air to pressurize the tank, and it will allow the other tank to be depressurized and vent out the nitrogen. The pure oxygen is then carried over into a receiver tank, and that then can go out to whatever application we are using. We use a thing called snowstorm filling for our zeolite. By using snowstorm filling, it means as the air comes in, you'll see that on the right-hand side there, that we have more surface area for the air to come in contact with. The more surface area the air comes in contact with, the more efficient the zeolite is going to be in absorbing the nitrogen. So we'll just show you a little bit here. I've just got a little, hope this works. There you go. So there's a little bit. This is snowstorm filling to make sure we get an even bed of zeolite into our columns, and that gives us more surface area, and that increases purity. So some typical setups, you're going to need a source of compressed air. You're going to need a filtration system we are talking high volumes of air. For nitrogen, it will be anything between 700 litres per minute up to over 4,000 litres per minute of air is going to be required for the process, depending on your output flow and how many banks of zeolite columns that you have. Air quality is going to be crucial to this, guys. Air quality is crucial. Now, we require a minimum air quality of 141, and I'll explain a little bit in our future slide just exactly what 141 actually means. But what you are going to need is air filtration system. We will go through that a little bit more in detail as we talk about the maintenance and we talk about fault finding on the system, what is going to have to be maintained within those systems. The crucial point to all this is pressure. If you lose pressure, then you're going to lose purity of gas, and that can also affect your output flow. So it's imperative that the filtration system is maintained properly to stop any pressure drops, which will cause problems downstream. Now, if I were to say, someone asked me right away, where is your biggest problem come from? Guys, it usually comes from the filtration not being properly maintained and either poor quality or low pressure going into the system. So this is what 141 means in air quality. First of all, it's the particle size. So you can see the size of particles that are allowed from the one. So up to less than 10 microns at 1.1 to 5.0 microns. So you can see that. The next one is vapor. Now, we normally use a refrigerated dryer. Now, a refrigerated drying system will give you approximately 3 degrees C dew point, and that's exactly what we want. And then the other one, we look at liquid aerosol or vapor oil. To get these high volumes of air is going to be required. The compressor will generally be an oil-filled screw compressor. So we have to make sure that oil vapor is removed from the system before it gets to the O2 generator. Right, safety, guys, I can't emphasize this enough. Safety is hugely important. Where concentrators you have been using relatively low pressures and very low flows, we are now talking about over 100 PSI of pressure, 7 bar going into the system, and we are talking from 700 litres up to 4,000 litres. So you have to take care with safety. Always refer to the manufacturer's manual and how to safely isolate a system before you do any work on it. So please, training. I do not recommend anyone working on a system that has not received training. Use the proper PPE equipment and make sure you know all the isolation points and the system has been properly isolated before you start any maintenance. So Why is maintenance important? On our system, there will be a service LED will come on to tell you it's due its yearly maintenance. I've already touched on why maintenance is so important. What we are talking about here is preventing poor quality air or preventing pressure drops. Through filtration systems will get clogged, especially if you're putting 4,000 litres a minute through those filters. They will eventually get clogged. They will cause pressure drops. Then we will see problems at either the delivery or the purity of the oxygen out to the user end. So again, just reiterating what I said, please make sure everything is isolated before you start any work on this system. So we're going to look at some of the things that will be done in our yearly service. We'll look at the silencers, we're going to look at the valves, and then we'll look at whether you have an O2 analyzer on it. O2 analyzer percentage will be probably what you will require, and that has to be serviced every 24 months as well. Now, a simple thing, guys. You're going to replace the silencers on a yearly basis. Now, the silencers are just not there to reduce noise. Yes, that is their primary function, is to reduce the noise. So why do we have to change them? Right? Silencers can get blocked. What happens in the PSA system? So you see we have two large silencers there, one for each bank of columns. If this silencer gets blocked at all, then what will happen is when the system goes to depressurize, it will depressurize slowly. We want this to depressurize very, very quickly. By depressurizing very quickly, you flush out all the N2 it's in there. If for any reason there's a blockage, and even if we reduce that depressurization by a few seconds, you are going to have problems with your purity. So indirectly, the silencer has an effect on the purity of the gas that you're going to produce. Again, on the valves, we're replacing the silencers on the valves to make sure that we don't have any problems with pressure not being vented as quickly as it should be. Non-return valves. Now, these non-return valves, PSA systems work 24 hours a day, 7 days a week. So a plant is going to run continually. It's not going to be used, well, in most cases, it's not going to be used occasionally. You're going to be running this if it's in a hospital environment. You want this to be running 24 hours, 7 days a week. And if it's doing that, the amount of workload on each NRV, shuttling back and forward as we take the air and the nitrogen, not the nitrogen, the air and the oxygen, and we pass it through these non-return valves. So they do wear and they do need replaced. Oxygen analyzer, we said every 24 months before we would actually repair the oxygen analyzer. So we are actually going to move on to the troubleshooting section of this. This is where I'm going to hand you over to Danny Livingston. Please, take any notes so that when we're finished the presentation, if you have any questions about the troubleshooting section or any of the presentation that we've shown you so far, then we'd be happy to try and answer those questions for you. So I'm now going to hand you over to Danny to take you through troubleshooting.
Hi guys, how are we all doing? Okay, so we're going to have a look at the troubleshooting part of our oxygen system now. Okay, so we'll have a look at the full setup that's required for us to produce this high quality oxygen. Okay, and there's a lot of parts that are associated. So we get, as Tom was telling us, the quality of gas going into the generator that's required. And this is so we can get the quality of gas on the output. Okay, so there's a lot of parts that need to be maintained. Okay, and if they're not maintained properly, these will cause issues with either the gas going in or the gas coming out. And it will show up as a purity issue. Sometimes it'll show up as a low pressure fault, but in turn that will essentially come to a purity issue eventually. So if you have a look at the full system setup we have here, we've got air compressors. The air compressor itself, generally speaking, will need a wet air receiver, and attached to that wet air receiver is going to be an auto drain. The auto drain is there to remove as much moisture as it can, because from the compressor side, a byproduct of compressing air is moisture, so we need to remove that. We've also got filters attached to the wet air receiver. These filter elements will have to be replaced annually to ensure the quality, and it's all about the quality of the gas going into the generator so we can give a good quality of gas coming out. We've also got refrigeration dryer. This will have filters inside it as well that have to be replaced, and it's all about just maintaining the system. Everything that comes from the wet air receiver on the auto drain or the filter with the auto drain attached, and the refrigeration dryer will have to go into, if it's an oil compressor, it will have to go into an oil water separator, because it's a condensate drain that comes from these things. You can't put it down the drain because it's got oil in it, so we need to separate the oil and water so we have clean water we can get rid of, and we've got oil stored that we can correctly dispose of as per wherever you are and the local legislation. We've also got a carbon tower associated with that. Now that will be necessary if you have an oil compressor, and as Tom was saying, because of the high flows that are required for this, the air compressor is more than likely going to be oil cooled or oil lubricated. So we need to remove as much of that oil so we can get to this 141 classification of air going into our generator. So the carbon tower, after the rest of the filtration is taking place, is to remove any of the oil that's still sitting in the system before we put it into our generator. Okay. Now, when we're looking at faults, the best place, in my experience, is to look at the start. Start at the start of the whole build. So the first place would be the compressor. Check for any faults in the compressor, and also check if it's been serviced in accordance with its recommendations. A lot of these compressors require quite frequent maintenance to ensure they are working correctly. Common faults, we've listed a couple of common faults on here, and a very common fault is a high temperature, and that will trip the actual compressor and it will stop production of compressed air. This could be normally due to oil level faults or something to do with the oil system, where it can't cool the air down, or it can't cool the actual compressor down itself, and it will be running very, very hard for a sustained period of time, and it will build up temperature, and it will have a temperature switch that will keep this in check to ensure the system temperature doesn't go too high. So the first place I would be looking, if you're starting to see low pressures on the oxygen generator, the peak oxygen generator, is go right back to the start. Look at the compressor itself. On the compressor, you'll see a screen, or you'll see some sort of log that will give you information on whether the compressor has been serviced or not. So it's a good place to start. It will also tell you what the working pressure of the compressor are, and also what the pressure the compressor is producing. Okay, and it'll give you a good indication if the compressor health is good. Then we're going to look at all the filtration that's associated with it. You can look at the filtration on our systems. The filtration that's required, as everything before the O2 generator is there to protect it. It's there to ensure anything coming out of the O2 generator is a high quality gas. Okay, so the filtration has to be periodically maintained. So the filtration will include, if you look at some of the pictures on there, you'll have filter bowls. Inside the filter bowls, there'll be filter elements. These elements will block over time, and if they do, then what you'll find is you won't get the flow going through the filter elements themselves, and this will lead to low pressure at the oxygen generator, which will lead to low purity issues. So all these parts have a knock-on effect on how the system is going to work. So we need to ensure all these things are maintained correctly. Okay, so the filter elements have to be maintained periodically. We've also got filter elements inside the refrigeration dryer. The refrigeration dryer is there to give us this 4 in the 141 classification of air, and it's a dew point that we're looking for here. So if you have a look at that picture there, the blue square with the Donaldson thing written on it, that is what we're looking at for refrigeration dryers. On the refrigeration, I'll start again. On the refrigeration dryer, there'll be a screen, or there'll be indication telling you when it's due for its service. And you have to ensure that all these components are serviced correctly and on time. If you don't do this, this is where your system will show poor purity. Okay. Also, you need to ensure where all these components are kept. If they're kept in a poorly ventilated room, it will increase the pressure in the system, the temperature in that room, which will in turn have an effect on the operation of the generator. So there's a lot of things to take on board here when you're doing this, but remember the outcome is a high volume of high quality gas. And to maintain that high quality gas, you have to maintain everything beforehand. And just start from the start, and that'll take you right through the system. The PSA generators will require a certain amount of air, and it has to be within this 141 classification of air like Tom was talking about. Okay. If you have anything, so if the maintenance is not carried out on, for example, the filtration or the compressor itself, and you get oil or water or any contaminants going into the zeolite, that can cause issues as well. Okay. And the issues that can be seen with, if it breaks up the zeolite, then it basically, the volume of zeolite in the towers will reduce, and you'll get movement of that zeolite. And the movement of that zeolite will break up, and it'll carry dust particles through, but your purity will be the first thing that you will see will start to suffer. Okay. We've got filters inside and outside of the generator. Everything, I can't stress this enough. The generators are very, very good, but you need to ensure everything is maintained annually and to the specification of the compressor specifications, the filtration, and also for the oxygen generator itself, to ensure that the quality of gas coming out is satisfactory. Okay. So we'll have a look at a couple of scenarios here. And we've got our input pressure not correct. So we'll have a look at here. And we've got a couple of images here for the check the valve lineup correction, and we'll check the isolation. So if we have a look here, we're going to ensure that our valves are all in the correct position. We've got a lot of valves in the system, and we need to ensure that we're not purging to atmosphere, that some of the valves are open in a correct sequence. And this is all detailed in service manuals. We need to open up and start the system in a procedure. We also need to shut the system down in a certain procedure as well to ensure that we maintain this quality of gas. Okay. Oh, sorry, I think I went the wrong way there.
Just to hit the back end again.
There we go. We're also going to check that inlet filters have been serviced correctly and the filter elements and auto drains. The auto drains are there to remove the moisture, are not blocked or full. Our filtration, basically our filter element is here. At the bottom of this, there will be an auto drain. The auto drain is there to basically sense the level of moisture that's been trapped by the filter and then remove it to the condensate, which is going to the oil water separator. So we need to ensure that the filtration is not blocked and also that the auto drain is working. If the auto drain doesn't work, if it's not being maintained or replaced as required, then you'll have moisture carryover or you can have oil carryover, which will damage the oxygen generators, which will show up as a purity issue. Also, the filtration itself, the elements themselves have to be replaced. If you don't replace them periodically, then they will start to block. And what you'll see is, you'll see a low pressure. You'll see low pressure, which will lead on to purity. And you can see where I'm going with this. Everything leads to the purity being affected. We're going to check all the air inlet pipework fittings and components are leak-free. So if we have a look at the image for this, on the generator there, we've got some pipework and we've got lots of fittings connecting this pipework to the external tank, as well as the oxygen generator itself. We need to ensure these are leak-free. If you look at the top of the generator, you can see there's a bottle of leak detector there, and that's basically what we would use to ensure there's no leaks in the system. And it's important to repair these leaks. If you have leaks in the system, the leak doesn't only come out the way, it also ingresses from the atmosphere as well, which can affect the purity of the system, and it'll show up as a purity issue. If it's a large leak, you could lose pressure in the system, which will show up as a purity issue. If it's a small leak, you can still might not see much in the way of a pressure drop, but you will see a purity issue. We're going to check the air inlet valve, and we're going to make sure that is closed. Okay, we've got two separate valves in the inlet. So we've got our isolation and we've got a commissioning valve. We need to ensure these valves are in the correct position for the generator to work correctly. We're going to check the pressure regulator as well. So internal to the generator, we have an output pressure regulator and we have an output flow controller. These are things you don't want to adjust. What you'll find is the system will be preset in the factory, and during installation, it has to be checked to ensure the flow is correct. Now, what you'll find is if the flow is turned up, so essentially, if we're looking at, just for argument's sake, we've got 100 litres output of oxygen, and we're sitting at 94% oxygen content. If we increase the flow out with the design of the generator, so if we take, for example, 150 litres or 200 litres, the generator might supply that, but your purity will go down, okay? Your purity will go worse because you've exceeded the flow design of the generator, okay? And that's an important part to just remember. The factory settings are there to ensure you have a steady, constant purity and flow of oxygen. If you affect these and you increase the flow output, then you will affect the purity. It directly affects the purity, okay? So that's something just to keep in mind. We're going to check basically what I've just already said, the output flow controller and the pressure regulator. We've also got a small portion we take off, and that's for the oxygen analyzer itself, okay? So we don't want to adjust that. It's adjusted in the factory. If you start messing about with any of the settings, it will affect the purity. And that's the most important thing to remember. Don't overflow the capacity of the generator. And it's not just for our generator, it's for any system that supplies a known quantity, a known purity of gas. If you affect the output, if you increase the output flow or the pressure without compensating for that with larger compressors, filtration, and everything that goes with that, then you will affect the purity. And that's the most important thing to remember. Okay. So, if the output pressure and flow are not correct, you'll use the test sheet for that generator, okay? And the test sheet for that generator will tell you what to set this at, all right? So you'll have your output flow controller and your output pressure regulator. You set it as per the test sheet, the generator's specific test sheet. And the test sheet will be unique to that generator, but it's generally the same for anything on that specific size. Correct pressure using generator pressure outlet controller using the test sheet. There's a test sheet right there, and that details all the information that's required to ensure that the purity of gas is maintained. We don't want to go higher than what the test sheet is telling us. We just work to that test sheet. Check the input pressure using the test sheet, and we'll check for system leaks using a leak detector. And once we've done that, we're going to close off the system and ensure it goes into eco mode. So once we've checked the input pressures, made sure they're correct, the input flow, we've made sure the compressor is maintained, all the filtration is maintained and working correctly, and then we're going to make sure using our test sheet that the system is set up correctly and there's nothing been altered. We're going to check for leaks in the system. If there's no leaks, if there's any leaks, they have to be repaired, obviously. But then what we're going to do is we're going to run the system. And we run the system until it reaches its designated purity. And that shouldn't take too long, maybe an hour or two. Then we're going to close off the output from the system. This is all detailed in the service manual. And that puts the system, we're going to check it goes into an eco mode. Now, eco mode itself means that if we have no demand from the generator, then the tank pressure, that's the process tank that's associated with the oxygen generator, should increase slightly. And as that increases slightly to more what the input pressure is, then we've got a pressure switch that monitors that, and it basically closes the system down. And that's basically to save any unwanted air usage. For example, if they're not using it for something like 3-4 hours, then it should go into this eco mode, and it should save air created by the compressor, because we all know air created by a compressor costs money. And then we just open up, and then it should go into its normal operation on its own. Yeah. We're going to have a quick look at purity, not correct or spiking rapidly. So we need to ensure the generator has had enough time to reach purity from startup. Now you need to consider everything that's involved in this. So the generator, when you first receive the generator, will be empty. There'll be no, we don't store oxygen and send it with it. All the tanks and pipe work, they'll just be ambient pressures and ambient air. So we need to ensure we can flow this through the system for up to 24 hours to ensure we clear the system of anything we don't want, so we can reach the purity of gas that's required. The oxygen sensor and analyzer within calibration, the certificate for that is inside the generator. If they're not within the calibration date, you have to look at either recalibrating or replacing. Check the analyzer and PLC have the same reading. What that means is inside the generator, there is a display that shows us what the oxygen content is. There's also one in the output of the generator as well. On the outside, make sure they read the same. We're going to check the system for leaks, check flows and pressures using our test sheet, as well as using, you need to ensure you have the right tools for that as well. So that would be a flow meter, some sort of flow meter that can measure up to 500 litres or whatever the output is. And we're going to check all the system, check the solenoid valves are securely attached, and we're going to check the carbon tower saturation gauge at the bottom to ensure it's not saturated. And that will give us a good basis to ensure the system works correctly and that oxygen content is maintained at the level that is required. Okay, so that's the presentation pretty much. So what we're going to do is we're going to take some questions now, if anybody has any questions.
Thank you so much, Tom and Danny, for that overview and that presentation. I think that was incredibly detailed and incredibly useful. We do have a question in the chat from Augustus. And I do have a couple of questions, and I think some others too as well. But let's start with this question from Augustus. He's asking, what percentage should an oxygen tank produce before it's being given out to the patient? I don't know, Augustus, if you want to add anything to that, you're always welcome to speak. Or Danny, feel free to take the question.
Right, I'll take this. Guys, what I would say is you guys are more the experts on that and what is required by the patients. The system will give you purities from 90% up to 94%. Now that purity is usually set at installation. So we don't usually intend to vary that purity throughout the life of the generator. So in speccing the system, you will spec the purity required, and that will be factory set.
Thanks, Tom. Fraser, did you want to just add on to that?
Yeah, just a very little bit that it's a hard one to put a definitive answer on. A lot of it depends on the application and how the instrument's being used. Typically, what you would find with O2 PSA plants is they are designed to produce what's called oxygen 93. So it's between 90 to 96%. I know certainly in the UK there's another standard, a medical standard, where our health service requires 94% or above. So generally speaking, it's very hard, and I think that's, you know, when you look at these, it comes back down to the specific application of how the instrument's being used.
Got it. Thank you. There is certainly a lot of debate around what oxygen purity is needed. So I think what we're all pushing for, especially from a WHO standards, is that anything above 90% is considered medical grade and can be mixed and used. I hope, Augustus, that answers your question. Peter, you have a hand up?
Good afternoon, everyone. A couple of questions. Refilling or changing out of the columns, can this be done on site, and how often?
The columns themselves, you won't refill on site. If you do have an issue with the columns, it can be replaced on site. And because of the filling procedure, if it's not done correctly, then what you'll find is it can cause a lot of issues. So the way we're filling it on in Peak Scientific is the correct way to fill it, and we know we don't see any issues with that. But you won't fill them on site, but you can replace them on site. They don't have a lifespan as such. We have years and years of experience with no issues. If the biggest problem that the biggest issue you find is if you saturate it with oil or you saturate it with too much moisture, and that can cause issues. And that's normally associated with everything that's associated with the generator itself. The generator is very robust. As long as it's maintained, it's very efficient, and it's very robust and works very well. But what you'll find, if the compressor side is not maintained correctly, if the filtration's not replaced periodically, then that's where you'll start to see the issues. But if you maintain everything associated with the generator as well as the generator itself, then you shouldn't see any issues with the zeolite compound at all.
Okay. Next question was the flow meter you were mentioning earlier.
Yes.
Is this supplied with the machine?
No, the flow meter's a tool that our guys carry with them, so it's part of their service kit or their tool kit that they carry. So it's not supplied with the generator. We set it all in-house, and we test every generator before it goes out. But our guys, when they do an installation, will basically check the flows and the pressures as well, just as a safeguard, like we do with any of our systems. So that's something that would need to be you'd have to have with you, but we don't supply it with the generator now.
Okay, thank you. And then last but not least, training on the units, and is that going to be, I presume that can't be done online, it'll have to be a practical course, and where would it be?
Training.
Right, okay, training, we have a peak global training sites throughout the world. We have training installations in North America, in the Far East, Singapore, and India. So where we have a global training center, then we can set up a virtual, well, we can do virtual training. That is possible. For something this size, I would recommend hands-on training, but that can be arranged at any of our global training centers.
Thank you very much, and a super presentation. Thank you, gentlemen.
Thank you.
So Tom, if I can maybe ask a question alongside what Peter just asked. Peak Scientific is relatively new to oxygen generators, right? It's your background is more in other gases. So there aren't a lot of peak products that are out, especially in the countries that most of the Alliance members are in. Does it make sense for somebody to visit a peak global training office if they're an Oxygen Alliance member, because there's knowledge and learnings there that are applicable to all oxygen generation plants?
Yeah, the basis of any, whether it's oxygen PSA systems, whether it's nitrogen PSA systems, the basics are all the same, right? So for whether it's Peak, whether it's another manufacturer of that, there may be the odd systems change and the way we do it, but all the basic components have to be there in place. All the same basic PSA system has to be in place. So if you take the training that would be offered from Peak, yes, you could take that training and you could apply that to other manufacturers.
Wonderful. So maybe we will call on you to offer a training session for any Oxygen Alliance members so that we can support other installations in their countries.
Yeah. Good.
Excellent. Do we have any other questions? Fraser, please go ahead.
Yeah, I don't want to put Tom and Danny, on the spot, but one of the things I was just thinking is the guys were delivering the presentations. We spoke a lot about service manuals, install guides, and test sheets. But and correct me if I'm wrong, Amapreet, but potentially some of these units that are out there in the field won't have that level of documentation with them, or it may be that they've been lost. So I think some of the fault finding stuff that you ran through, Danny, may be able to help that. But it was just if there was anything else. If we were to assume that level of documentation wasn't present with the generator, is there a good place that people could start with or start from?
For
any
units?
Yeah, for fault finding, or for, if the service manual or the install guide wasn't there, is there something that they could start with, assuming it wasn't a Peak unit? Yeah,
if it's not a Peak unit, what you can do is everything's labelled. So you have your one compressor will have a manufacturer on it, and you'll be able to go to that manufacturer and get information on that. So everything's generally, it'll be the same as what we do. Everything's labelled, everything's logged, everything has a serial number and a name on it. So you should be able to trace back the information for that particular system. But they all work very, very similarly. So if you have a basic outlet, a basic knowledge of how, for example, oil screw compressor works, you can use that information to quickly fault find on a compressor. If you have an auto drain, they all generally work with the same principle. So if you've got a general understanding of how that works, you can pretty much fault diagnose that very quickly. And also most of the filtration will have an indication if there's a high pressure differential across the filtration itself. That's an indication. It might be a red flag comes up, or it might be a digital reading saying it's maybe in millibars or whatever it may be. But all these things are on there, and they're very standard across most of the systems. But if you do get stuck, I would just go to the manufacturer of that and see if they can give you any information for that. But the basics behind how all these things work are very, very similar. And if you've got a basic understanding, you can certainly fault find very well by just using the basics of compressed air, filtration, auto drains, refrigeration dryers, things like that. It's not overly difficult, but you need to have a basic understanding if you get what I mean.
Yeah, you know, I mean, a simple thing like refrigerator dryers, there's, you know, 10s, 20, 30, 40 different manufacturers out there making refrigerator dryers, but they all work on the same principle. You know, they all have to have the same components. Where those components are, maybe in different places, but they've all got to be there, right? So by, you know, obviously Google is great. You know, we're using it here too. You Google, you know, that manufacturer, their refrigeration dryer, and then they'll even point out most of what the common problems will be. But with any refrigeration dryer, it doesn't matter the manufacturer, the common problems are going to be filters and auto drain. That'll be your problem in the majority of the scenarios that you're going to come across, either the filter or the auto drain's not working correctly, and that applies to everybody.
Got it. I guess one last question from me. We talked a lot about the specific components, and I've got at least a little bit of an understanding of the compressors that are involved with a PSA plant. For filters, for the dryers, are they typically unique to each manufacturer, or would somebody be able to go to Peak and say, hey, we've come across a different PSA plant, but we can't get the filters from that manufacturer. We can't figure out who is the manufacturer. Are there alternatives that can be used or found from like a secondary market?
Yes, of course. The filtration, what you find is filters are sized by flow going through them. So as long as you have the same type of filter, so you get different types of filter, and they'll be in different points and throughout the system. So you might have a coalescing water filter, which will basically be there to remove moisture. Might get a particulate filter that's there, and they'll have markings on them. So if there's no markings on the one you have, all you need to do is know where it is in the system and what kind of compressor it's coming from, and you can pretty much figure out with the rest of the system what it is you need. If it's, for example, a cyclone filter is there to remove as much moisture as it can, or a paper filter for removing particulates, or whatever it may be, you can use other filters in place as long as they are sized correctly. They have to be sized correctly. But you can mix and match different companies' filters without any issue. As long as it's the correct filter and it's sized for the flow going through the filter, that's the most important things.
Fantastic. Well, we are at time. So thank you very much from all of us at the Auction Alliance. Sharon, we will try and squeeze her question in if that's okay. We'll go a little bit over. Thank you. Sharon, go ahead.
Thank you. You mentioned that you use the screw compressors in the PSA plant. Is there a reason why you use these type of compressors? Can you also use other types of compressors, such as centrifugal or reciprocating compressors?
Yeah.
Thank you.
Yes, you can use any compressor you want. The biggest issue we have is the amount of flow that's required. Because of the purity of gas is so high and the pressures are quite high. you could use a piston compressor if you want, as long as it can supply the correct pressure and volume that's required for the rest of the system. You can use a scroll compressor if you really want to, but the price of them is quite high for the kind of flows that are required. So you can use any compressor you want, as long as it supplies the correct pressure and flow. But remember, for any pressure, for any compressor that you use, you have to ensure you remove the particulates, the water, and the oil to the correct level using filtration. But yes, you can, short answer, yes, you can use any compressor you want, as long as it can supply the volume and pressure that is required.
Yeah, I'll just come in here. What you'll find is the more oxygen you want out, the more gas or air you need going in, and you are now looking at 10, 11, sometimes 12 to 1 ratio of air going in to oxygen coming out. And the only way you're going to supply those high volumes is by an oil-filled screw compressor, basically. Once you get up to that, there is no other method. Yes, if you're taking lower flows, you have more options on the type of compressor you use. We're not saying it must be an oil-filled screw compressor. What we're saying is, once you get to high volumes, there is no other way in providing that type of quantity of air required.
Wonderful. Well, thank you so much, Fraser, Danny, and Tom. We really appreciate your time. You are, of course, always welcome to join us on the other concentrator talks going forward. But we will return to our regularly scheduled programming next week, Thursday at 2 o'clock Central African time. Thank you again to Peak, and thank you to everyone for joining us today on this call.
Right. Thank you very much for the opportunity.
Thank you.
Right. Bye.
Thank you. Bye-bye.
Thank you.
Bye.
Thank you.